Welcome to this video on using the rules of logs. We're going to go through some examples, and as we go through the examples I think it would be beneficial to have the rules of logs open in front of you. So there's a picture of it here, and these appear on page 21 of your log tables. So we're kind of working with the second two columns, and as we go through them I'll be referring to different rules, so if you have your own, do have them open now, or even pause the video and go and get them. So let's take a look at a question here that asks us to simplify the following expression. So there's a few different expressions here with the logs. So let's take a look at example 1. So it's asking us to simplify the following expression. So we can see that this expression contains 3 sets of logs. So they want us to write it in the simplest form. So the first thing that we see is that we're adding 2 of them and we're subtracting a third. Now we do have rules about adding logs, so if you look at page 21, in the second column we're looking at the top rule. So the rule says log to base a of xy is equal to log to base a of x plus log to base a of y. So basically if we have 2 logs, so this is kind of working from right to left, if we have 2 logs that have the same base, so the same base, we could simply multiply the 2 numbers. So when we look at the first 2 logs here in front of us, we should be able to apply that rule. However, with both of these, one contains a 3 in front of, one is a 3 in front of it and one is a 2 in front of it. So if you go back to your log tables, the rule that we have, they're both just log. There's nothing in front of it. So we're going to have to change that in some way. So if you look at, again, the second column on page 21, there is about, on the third line down, it says the log to base a of x to the power of q is equal to q log to the base a of x. So when there is a power on the number, it can be brought down in front of the log. And working the opposite way, when there is a number in front of the log, it can be brought up as a power. So this changes this log to log 2 to the power of 3 plus log 3 squared. And then we can also at this point rewrite this log as log 6 squared. Okay, so now I'm going to start applying my rule. So my rule here is multiply. So I have log 2 to the power of 3 by 3 to the power of 2. And I have a minus log 6 squared. Now, the second rule in the second column tells us that if we subtract 2 logs, we can use division. So that's the rule that we're going to use now. So we'll have log, and now we have 2 to the power of 3, 3 to the power of 2 over 6 to the power of 2. So if you simplify 2 to the power of 3 by 3 to the power of 2 over 6 to the power of 2, you'll get that that simplifies simply to the number 2. So that is as simple as we can make that expression. So example 2. So now this is an equation. So in the first example we were working with an expression and we were just trying to simplify it, so to combine the logs. Now we're working with an equation. If you remember, an equation contains the equals, and when we have an equals we will be asked to solve. So we want to find a value for x. So as you can see, there are 2 separate logs here, one on the left hand side and one on the right hand side. Like any equation that we deal with, we want to try to get our logs on one side and our numbers on the other. So we're used to this. We usually try to get our variables on one side and our numbers on the other. So let's say 4 equals log to base 2 of 2x, and this becomes a minus 2 log to base 2 of x. Now, we have 2 logs, we're subtracting them. So if you go to page 21 in your log tables, we're probably going to have to use the second rule. However, just before I use that, we have a 2 here. that we need to deal with. How we deal with that, it's the third rule down in the same column, and that basically tells us that if there is a number or a coefficient in front of the log, it can be written as a power. So this is log to base 2 x squared. Now I can apply the second rule in that column, which basically tells me when there are two logs with the same base and they're being subtracted, I can use division. So this becomes log to base 2, and the division is 2x over x squared. Now, so let's simplify that even more. So log to base 2, and it becomes 2 over x. Now, we're nearly there to solve it. I have a log on the right hand side, and I'm unable to put that into my calculator because there is a variable in it. When this happens, we have to convert the log to an indice. Now, there is a rule to do this, again on page 21 of your log tables, and it's the very top rule in the third column. So I'm just going to put the rule here just so we can use it. So it says a to the power of x equals y, and that converts both ways, and you get log to base a y equals x. So if we go to our little equation here, we're looking at this piece here. So this is my x, and this piece is my a, and this piece is my y. So rewriting it, we have a, which is 2, the power of x, which is 4, is equal to y, which is 2 over x. Okay, so we'll multiply both sides by x, because that will allow us to get rid of the fraction. Oh, apologies. So we have an x here. So 2 to the power of 4 is 16, so we have 16x equals 2. So x is equal to 2 over 16, which simplifies to 1/8. Okay, so that is how we would go along to solve the equation. So we want to use our rules of logs to simplify the logs as much as possible, because we can only use our rule to convert the logs to an indice when we have one log equal to a number. So we do need our rules here. So this shows you how you would apply the rules in a different question. Now let's take a look at example 3. So this is the equation involving logs. However, the logs have different bases, and that means that we can't use the rules straight away until we deal with this. So what we're going to do is we're going to use a formula that appears on page 21. This formula is the bottom of page 21 on the right hand side, so it's the bottom of the third column, and the formula is the log to base b of x is equal to log to base a of x all over log to base a of b. Now what we're dealing with here, our b is 9 and x plus 2 is our x. So let's basically sub this in. So we have log. Now this is to base a. A is not given in our original log. A is actually the base that we want. So because we want this to match the other log, we're going to use base 3. So the x is x plus 2, and that's all going to be over log to base 3 of 9. Now, you'll notice on that bottom line that it's all numbers, so we're able to stick that into our calculator and get an answer. So the top line is still log to base 3 of x plus 2, and the bottom line will give me 2. So putting it all back into our initial equation, we basically get a half. So instead of writing this over 2, I'm pulling it out in front and writing it as a half. So log to base 3 of x plus 2 minus log to base 3 of x, and that equals 0. Now, like before, if we have a coefficient in front of our log, it becomes a power. So that is the third rule in the second column on page 21. So this becomes log to base 3 of x plus 2 to the power of a half minus log to base 3 of x equals 0. Now that we have two logs of the same base, we can apply the second formula that appears in the second column of page 21, and that says if two logs are subtracted when they have the same base, we can simply divide. So that's what we'll do. Log to base a of x plus 2 to the power of a half all over x, and that should equal 0. Now at this point we want to convert, apologies, I put an a in here, now that should be 3. So at this point now we want to convert this log to an indices so we can finish it. So what we get is we get 3 to the power of 0 is equal to x plus 2 to the power of a half over x. Now at this point you do need to remember that anything to the power of 0 is 1. So we get 1 equals x plus 2 to the power of a half all over x. Okay, so let's keep going with this. So we're going to multiply both sides by x, so we're left with x equals. Now, instead of a power of a half, I'm going to write this as a square root, x plus 2. Now we're back to a third equation. So here we can square both sides, so you get x squared equals x plus 2. And we can bring this all over, x squared minus x minus 2 equals 0. And we can factorize. So our factors for minus 2 are going to be minus 2 and a plus 1, which solves it as x equals 2 and x equals minus 1. Now, both answers are not valid because if you come back to the initial question, they told us x had to be greater than 0, which means this answer is not allowed. And this x equals 2 is our correct answer. So just beware when they provide you with some kind of limitation in the question, or some idea that it cannot be a specific answer. Sometimes that comes into the answer, sometimes it doesn't, but do keep an eye on it just to make sure. So the last example now is we're going to take one from the exam papers. This was 2016 paper 1 question 4. Now there was two parts to this. I've only taken the second part, which was just that little bit tougher. So they've told us that log to base a of 2 is p. So this is the first thing they told us. So we can rewrite anything log to the base a of 2 as p. And they told us here log to base a of 3 is q. Okay. So now they've provided us with the log to base a of 9a squared over 16. So we're used to working with the formula on page 21 going from right to left, but actually this time we're moving from left to right. So the first thing we notice is that in the top line and a bottom line, so there's a division there. So using the second rule, so the rule that appears in the middle column, second one down, I'll get log to base a of 9a squared minus log to base a of 16. Now, neither of those are quite what we're looking for. However, you might notice that we have log to base a of 16. Now, 16 can be written as 2 to the power of something. Okay, so we are going to have to deal with that. You might also notice that we have 9a squared. So 9a squared means 9 multiplied by a squared. So we're actually going to use our first rule here and apply it to the first piece. The first rule tells us that when two numbers are multiplied, we can use a plus to split the logs out. So we get log to base a of 9, log to base a of a squared. Now we have log to base a, and now instead of 16, I'm actually going to write that as 2 to the power of 4. So now, still have a little bit of work to do because I need either a log to base a of 2 or a log to base a of 3. You might be able to see here that 3 can be written as log to base a 3 to the power of 2 plus. Now, in your log tables, On the third column on page 21, the second rule down, it says log to base a of a to the power of x is simply x. So when you have a base and a number that are the same, like we have here, the answer is just going to be the power. So in this case, this will just simplify to 2. Now, we had log to base a of 2 to the power of 4, but we were simply looking at log to base a of 2. Now, the third rule in the middle column, we've used it before, but maybe the other way. So it told us if a number is in front of the log, we can bring it up to the power. Similarly, if there's a power, we can bring the power in front of the log. So this becomes log is a of 2. Now we can do this here with the log a3 as well, because it was squared. You can bring that down in front. 2 minus 4. Now instead of log to base a of 2, I can replace that with p as given in the question, so we're nearly there, and I can replace log to base a of 3 with q. So this all simplifies down to 2q plus 2 minus 4p. Now, as straightforward as that was using the rules, it was quite a tricky one to see because we're not used to seeing the rules work in that way. We're used to seeing it going the opposite way. So it is important to see as many of these examples as you can to make sure you're happy to attack or approach any question that you see.